Hey, hi. Uh, I'm presenting the peer graded assignment of my course, AI Product Manager from the Duke University. Let's see the problem statement. We students need to build a predictive model to estimate the net hourly electrical energy output of the combined cycle power plant using the ambient environmental variables such as temperature, pressure, humidity, exhaust, vacuum. The goal is to accurately forecast the energy output to optimize the power plant operation. Okay. So I think this is a clear-cut regression problem as we aim to predict the numerical value of net hourly electrical energy output, which is P based on the environmental variables like temperature, ambient pressure, relative humidity, and exhaust vacuum. The appropriate output metric for evaluation could include MSE, MAE, score for assessing how well the model explains the variance. How the data gets splitted, like 80% of data goes to a training set and 20% goes to a test set. Further, I will be utilizing the k-fold cross validation. uh, there are two model I'm going to utilize. One is linear regression and random forest regressor, and models have been getting evaluated based on the cross validation, RMSE, a test set RMSE, and R square score. The total records I received are 9,568. Let's see how the model will look like. This is my Python code. I will be utilizing the libraries like pandas, NumPy, Matplot library, cfon, and for building the model, I'm using the sklearn library. Okay, so the first section will be I'm uh, using PDR, read SEV, like taking the input from the file. Then I am preparing the correlation metric, then splitting the data into uh, dependent and independent variable X and Y, and like splitting the data into test and train, then initiating the model, then using cross-fold validation for linear regression, then fitting the model, or you can say like training the linear regression. Similarly, I will be using the cross validation for random forest model and then training the model. Okay, and then evaluating the result for the both model, so we able to understand which is performing better. And then I will be also added some more coding. So I will take the input from the user, and based on that I will predict the output. Okay, let's see how the code will work. I'm executing the code. Okay, this is my correlation matrix. It is showing the relation between the features, how they are like closely related to each other. What is the correlation, whether it is direct correlation or inverse correlation. Inverse is showing by blue color, and direct relation is highlighted by the red color. Okay, so after this, let's see. Okay, this is a feature importance from random forest, which feature has an importance over here. Okay, so it is showing ambient temperature. That's fine. Let's see the next execution of the code. So it is asking me the input, and based on that, this model will predict. Let's put some values. The ambient temperature. So if I go and check. Okay, the ambient temperature should be in between 1.81 to 37. So I will take 37 here. Then it is asking me for exhaust vacuum. So it should be between the range of 25.8 36 to 81. I will go at a higher end. 81. Asking me for ambient pressure. Ambient pressure should be between 99 and 2. 1000. I will take 1000 over here. Next, it is asking me about relative humidity. Should be okay, 100. So based on my input, model has predicted for linear regression, the prediction are 408, and for random forest, the prediction are 432. If I check the evaluation model result, it is clearly showcasing. Let me show the slide so you're able to understand it more better way. So these are my evaluation scores. So linear regression, as you can see, the R square score is 0.93, which is indicating that it explains 93% of the variance in energy output. And compared to that, random forest has the score of 0.96, which is showing it explains 96% of variance and provides more accurate prediction than linear regression model. So this is how uh, the model will work. So I will stop here. Thank you.